Metallic bond. It is the electrostatic force of attraction between the positively charged centers and negatively charged delocalized electrons in metals. In order to understand this, metals are made up of atoms of the same kind. Like sodium is made up of many sodium atoms of the same kind. These atoms have weak forces of attraction between the nucleus and the outer electrons. Now, from this diagram, the nucleus is represented by the orange circles with a positive charge. So the attraction between the nucleus, that is positively charged, and the electrons, the outermost electrons, that is negatively charged, is weak. This makes the electrons free to move about the metal structure. So the electrons could move from one atom to another and another, but within the metal structure. This forms a pool of electrons or a cloud of electrons around the positively charged centers. Now, the positively charged centers and the delocalized electrons have what we call an electrostatic force of attraction. This force of attraction results to a type of bond known as metallic bond. For example, sodium has a positively charged center and one delocalized electron. So one electron in the outermost energy level is free to move about the metal structure. So we call it a delocalized electron. Magnesium, which is in group 2, has two delocalized electrons because it has two electrons in its outermost energy level. Aluminium, on the other hand, has three delocalized electrons. Now let us take an example. Group 1 elements would be drawn as shown here. You see that every positively charged center has one delocalized electron. But for group 2, the positively charged centers, each positively charged centers has two delocalized electrons. Now for metallic structures, it is important to note this difference because the delocalized electrons are responsible for some properties of metals. For example, delocalized electrons are responsible for electrical conductivity. Meaning, the delocalized electrons are the ones which carry electrical charge from one point to another in the metallic structure. So, for group 2 metals, they would be better conductors of electricity because they have more delocalized electrons compared to group 1 elements. So, specifically, you could say magnesium is a better conductor of electricity than sodium because magnesium has two delocalized electrons while sodium has only one delocalized electron per atom.